Hello, and welcome to our presentation today on getting senior management support of performance initiatives. Today, myself, Craig Mullins, and Randy McCoy, CFO of DataKinetics, are going to talk to you about this important topic. And really, it's going to be broken down into two parts. The first part, delivered by me, will be on performance issues, focusing more on DB2, and even more so focusing in on I/O issues. That's one component of the performance makeup. And then after that, Randy will walk us through how to talk to non-technicians and people who control the budget to make them understand and get the right perspective on what the problem is and how it impacts the budget. Because you can have all the performance problems in the world and solutions to them too, but if you can't explain to somebody how the tooling solutions are going to impact the bottom line of the organization, you probably won't get anything done. Okay, so with that said, a brief introduction to myself. My name is Craig Mullins. I'm an independent consultant focusing on DB2, DB2 Gold Consultant, and IBM Champion. Wrote a couple books, one on DB2, one on database administration. And if you're interested, here's my contact information. With that out of the way, let's move into talking about the technical side of performance issues and DB2 I/O. First, some general observations. Left to their own devices, DB2 for ZOS databases and applications are going to start to accumulate problems over time. You know what I mean? Things that used to work stop working, and that can happen for any number of reasons, including maybe you've added more data, you may have reduced some aspect of business data. You've got different types of data now. With all the big data phenomenon coming in, we've got more than just your text and numbers like we used to have in the past. Maybe there's changes in busy periods or business shifts. The software may have changed, new version of DB2, new version of interacting software, hardware changes. I mean, you get the idea. There's a lot of different things that can change. And there's always the possibility of remnants from the past causing issues with your DB2 environment. Some things may have been implemented suboptimally from the start, maybe many years ago, or perhaps even more recently. And keep in mind, DB2 is not a static piece of software. It changes over time with new versions. You get new features, new functionality, and as these new capabilities are introduced, older means of performing similar functionality might become suboptimal, and maybe in some cases even obsolete. So you've got to be able to identify those artifacts, but that can be troubling. And it's not likely something that a DB2 is going to do on a daily basis. Nevertheless, the performance and availability of your DB2 environment, and therefore the business systems that rely on DB2, can suffer if you don't pay attention to the health and welfare of your DB2 databases and applications. So it makes sense that you should be regularly monitoring, administering, and managing the changes that are happening in your DB2 environment. I mean, that's really the only way you keep your production systems functional and operating efficiently and effectively. Now, of course, these functions can be costly and time-consuming, and you may need additional software to perform the appropriate amount of performance management. And as we all know, that may not be possible because the expense may not have been budgeted, probably wasn't planned for, so things get bypassed. The message of what is necessary gets skewed because the technical and finance folks don't speak the same language. So hopefully we'll be able to break down some of that miscommunication today. So where do we start? If you think about performance, there are three primary things that go into the performance equation. So you're looking at it, and it's CPU, it's I/O, and it's concurrency. You may be doing lots of changes, and there are lots of things you can do in a DB2 environment. But if you've got a performance problem and you're making changes and you're not impacting at least one of these three things, fine, you're making changes, but you're not impacting performance. We want to be reducing CPU usage, reducing I/O activity, and increasing concurrent activity. Any one of those three things, or those three things in combination, can help to improve performance. Today, the focus is going to be on I/O. So let's break down the I/O aspect of performance tuning in just a little bit more detail. When less I/O is needed to perform the same task or to produce the same output, then there's going to be less overhead involved. Fewer I/O operations means less elapsed time, but also potentially less CPU time. We'll see why that is in a minute when I go over what all goes into an I/O operation a couple slides down the line. Anyway, there are a lot of modern improvements that reduce or eliminate, in some cases, the need for costly I/O operations. There's cache on storage hardware that keeps recently or repeatedly accessed data in memory on the device, the storage device that is, instead of on the mechanical storage plate. So we're reducing latency there. And there's also in-memory technology that can be added to your applications that can minimize the impact of I/O operations. There's in-memory application software, in-memory technology that can be added, and in-memory database management systems. An example of using software to store data in memory instead of on disk is DataKinetics table-based product. If you can replace the disk I/O with in-memory access, like table-based can, in some cases you can significantly improve the performance of data access in your applications. There's a white paper at the bottom of the slide referenced here that's a good place to start if you want to look for additional information on table-based. So I/O can be an issue, but how do you know that an application is I/O bound? In other words, performance is being impacted because it's waiting on I/O operations to continue processing. Well, there's a couple things that are shown here on this slide that can indicate that you have an I/O issue. Maybe the CPU is being underutilized. The system may not be stressed, but jobs aren't completing effectively. Or you can see CPU utilization, by looking at RMF reports. So look at the CPU utilization. If you see that it's not being it's underutilized for what you would expect at certain periods of time, it's possible that lag in I/O operations, waiting for I/Os, is the issues. Maybe your batch jobs are out there running for a long time, or maybe your transactions are experiencing poor interactive response time. These things can be indicators that maybe there is an I/O issue. And in general, if you see excessive wait time, that can indicate potential I/O issues. So there are these indicators that you can look for that says I'm being strained at the I/O level. Okay, now maybe moving the data to memory can help. It may seem to be common wisdom that memory outperforms disk, but why is that so? I touched on it a little bit earlier. Disks are mechanical, so there's latency, wait time, between a request for data and the delivery of that data. The channel subsystem directs the flow of information between I/O devices and main storage. It relieves CPUs of the task of communicating directly with I/O devices and permits data processing to proceed concurrently with I/O processing. The channel subsystem uses channel paths to manage the flow of information to or from I/O devices. Now, there are other things happening when an I/O occurs too, and as I mentioned earlier, we'll break that down in a couple slides. Okay, so if the data is in memory, then there's no mechanical latency. The data requester doesn't have to wait for the platter to spin to the correct position or for the disk arm to position itself correctly. Now, there is latency. Reading from memory is not instantaneous, but compared to disk I/O, it might as well be. So why isn't all data stored in memory instead of on disk? Well, there are quite a few reasons why you can't do that. There's cost. Memory costs more than disk. There persistence of data issues. If it's in memory and it hasn't been backed up to a log somewhere or to disk somewhere, if the computer goes down, the memory goes away, and then you have data integrity problems, size issues. You can't store everything there because there's just not enough memory to put megabytes or terabytes of information into main memory, and so on. So there are issues as to why it can't all be in memory. But using in-memory techniques to store data is becoming more common. In addition to software like DataKinetics TableBase, which I mentioned, we also see more in-memory database management systems that are becoming more popular. You may have heard of things like SAP's HANA, or IBM's SolidDB, or Oracle's Times 10. These are database management systems, and they've been specifically engineered to store and access data in memory. And there are specific applications that have taken advantage of this technology to enhance the performance of accessing data. So the issue with an in-memory database, though, is that it's a different DBMS, and that may not be conducive to the development environment. So there are other things. There's flash storage and solid-state disk products that are designed to mimic mechanical disk devices, but without the moving parts. So maybe something like IBM's flash system V840 with real-time compression. There are other flash systems out there and other solid-state devices out there that can be used to move the data into memory. Okay, this is the slide I've been promising for a couple slides back. We're going to take a look at what all that can be involved with an I/O. So what this shows is all the complexity behind the scenes that can be happening when you ask for an I/O. So look at the numbers. I'll reference each number as I read through what's going on here. Number one, the user program begins an I/O operation. It issues an open instruction requesting either input or output of data using I/O instructions like get, put, read, or write. And it specifies a target I/O device. An I/O macro instruction invokes an access method that interprets the I/O request and determines which system resources are needed to satisfy that request. As we go on to number two, there are several MVS access methods, each offering different functions to the program. The selection of an access method depends on how the program plans to access the data. Is it random? Is it sequential? And the organization of the data set. Is it sequential, vSAN, PBS, so on. Number three, to request the movement of the data, either the access method or the user program presents information about the operation to the EXCP processor by issuing the EXCP macro instruction. What EXCP does is translate the information into a format that's acceptable to the channel subsystem. It fixes the pages, checks the validity of extents, invokes the IOS, the IO supervisor within the channel subsystem. At number four, the IOS places the request for IO on the SAP queue. Okay, that's not SAP, the ERP package. That's the System Assist Processor. This is a processor in IBM mainframes. And it does that for the chosen I/O device in the unit control block, or UCB. At this point, the central processor can continue with other work until the channel subsystem indicates with an interrupt, an I/O interrupt, that the I/O operation has completed. Okay, so we're doing these things at the same time. We're requesting a read. If there's other work that can be done, go ahead and do it while the I/O is processed until the interrupt comes back. Number five, the channel subsystem selects a channel path to initiate the I/O operation between the channel and the control unit or device. This controls the movement of data between the channel and processor storage. Okay, number six here. A control unit or fiber director is selected from the I/O configuration dataset, or IOCDS, and that can access the devices where the requested data resides. Moving on to 7, the connection to the device lasts as long as necessary for the device's sensor to reach the track on disk where the data is located. We move to number 8, and the data is placed in an available buffer from the controller's buffer pool, and it gets compiled into the appropriate frames in order to be transferred back to the channel subsystem. And then we move to 9. Once the data is transferred back to the controller, it disconnects for the next I/O, freeing its buffer and returning it to the pool. At number 10, when the I/O operation is complete, the channel subsystem generates that I/O interrupt I was talking about, and that's handled by a special system routine called FLIH, or the first level interrupt handler. There are 6 different types of interrupts within ZOS, where I/O is one of them. Number 11, back to the SAP, that processes the interruption by determining the status of the I/O operation, whether it's successful or otherwise, that came from the channel subsystem. It uses a test subchannel instruction to do that. At number 12, back to EXCP, which indicates the I/O is complete, by posting the status to the access method and calling the ZOS task dispatcher. Here we are at number 13. The dispatcher reactivates the access method if necessary. And at number 14, the access method returns control to the user program for redispatching by the ZOS task dispatcher to continue its processing of the next executable instruction. Okay, don't worry too much about all of what I just went through. I'm not going through this to try to tell you you need to understand and know all of this. The point was to make sure you understand that there is a lot going on when an I/O occurs. And you can see now why minimizing this can help to improve performance, right? So a lot of different things can cause I/O problems, especially in DB2. At the top of the list, of course, is the SQL statement, how it's written, how it was optimized by DB2. Is it a table space scan? Are we using an index? Is there prefetch going on where we can load up the memory structures, the buffer pools with data, sort of saying we're going to need this beforehand before we get to it, load them up. That's probably the most important part. Physical aspects of the database structures, too, can cause I/O problems like poor data clustering or disorganized table spaces and index spaces. Maybe the buffer pool, the memory, isn't set up properly or configured or tuned effectively. If you don't have enough memory assigned, or maybe there's improper thresholds for deferred writes and sequential versus random access. The buffer pool is there. When data is in the buffer pool and it's written to the log, DB2 says, hey, it's been made. So it has to eventually be written from the buffer pool to disk, and that is the deferred write threshold. So all these things can impact performance. There's always the possibility of contention at the hardware level too, down here. That can cause waits. Or maybe you just need to read a lot of data, maybe once or the same data over and over again. All these things are potential issues. So what types of things should you check? Well, look at the wait times. If you have wait for synchronous I/O, synchronous meaning the I/O has to happen before I can do anything else, well, that can significantly slow down your application performance. As a general rule of thumb, an asynchronous read, meaning go out, get the data, and do other things waiting for the data to come back. This is sequential prefetch or sequential detection. That requires about 0.4 to 2 milliseconds per page, whereas a synchronous write requires about 1 to 4 milliseconds per page, so a lot more expensive. You can look at tuning for prefetch by configuring buffer pools better for sequential access, tuning the thresholds, moving database objects between buffer pools, tune for the type of access that are typically required. Or you can look at other methods of moving data into memory, like staging a table completely into a buffer pool. When DB2 comes up, I got a buffer pool configured, small enough table that it fits all into the buffer pool, do a staging read, scan all of it, put it into memory, and it's going to stay there as long as nothing else gets in and moves it around. Or you can look at using something like DataKinetics table base. Anything to reduce the expense of I/O processing can be important if you've got excessive wait times. Okay, real quickly, I did mention sequential prefetch, but I didn't really explain it. This diagram kind of goes through that. Sequential prefetch is an asynchronous read engine, and it kicks in when DB2 figures that you're reading data sequentially. It's part of the access path. It's also possible, even if it's not part of the access path, that as it starts running, DB2 invokes sequential detection and says, hey, you're accessing things sequentially, kick it in. Okay, what is it? It prefetches, reads the next group of data pages into memory before they've been requested. So if you've read a page, read the next page, read the next page, DB2 says, aha, sequential processing. Go out and grab a chunk of pages, 16 pages, 32 pages, read them all into memory. So the next time I request a page, I don't have to do an I.O. It's already been done asynchronously behind the scenes. I request the I.O., I get it from the buffer pool. This diagram came from my book, DB2 Developer's Guide, and there's a description of that in that book if you're interested. Okay, I've mentioned some things to look at, but not really how to get the information. I'm going to give you some examples of that. And most organizations have DB2 performance monitors that can deliver information either to an online screen or a batch report. And the next couple of slides show some of these reports. They're basically DB2 PM accounting reports that can be generated from Omegamon, but things like main view, the CA, the TMON monitors from Allen Systems, generally they have similar looking reports. So don't get too hung up on what the report actually looks like. Just think about the category and what's on it. And the first type of report to consider is the DB2 accounting report set. And that provides information on the performance of DB2 applications. Okay, now remembering the presentation we're in here where we're talking about technicians versus business people, keep in mind that the term accounting doesn't mean the same thing in the context of DB2 performance as it does to an accountant or a CFO. An accountant will be no more comfortable with this report than a DBA would be with the detailed financial statements and reports that a CFO uses. Okay, so back to the DB2 accounting reports. There's two basic layouts, the short and the long report, and the short report shown here on this slide, and it provides basic information on the performance of DB2 programs like start and stop time, number of commits, aborts, type of SQL statements and how often each type was issued, buffer requests, locking, CPU resources, asynchronous and synchronous I.O. wait time. These are things that you look up here in the synchronous read and the total prefetches and the get page and the buffer updates where we're looking at I.O. related information. So lots of good information at a program level. If the short accounting report signals that potential problems exist, then a long accounting report can be requested. And this goes into much more detail for each entry that's on the short accounting report. So this documents performance information in great depth and is one of the most useful tools for performance analysis. There's 9 distinct sections on various aspects of DB2 performance. I'm not going to go into all of them, but suffice to say, a lot of good information here. Start with the short report. You see issues for certain programs, go out and get the long report if that can help you. And because I've been talking a bit about I.O. issues, take a quick look at the buffer pool section of the long accounting report. This can be a really good resource for figuring out the effectiveness of your DB2 buffer pool usage. We won't show the overall effectiveness of the buffer pools, but the effectiveness for the specific program being reported on. Remember, accounting reports are at the program level. So this shows the buffer pool for the program that it is listed under in the report. You can also look at an I.O. activity report. The monitor may show that, batch report can show that. Groups the I.O. activities into report blocks showing I.O. details for the logs, active and archive, the bootstrap data set, your buffer pools, the EDM pool, and more. But I don't want to get too far into the weeds here. The goal here is just to show you that there's detailed information available to find your I.O. issues if you've got a performance monitor and reporting tool like this. Okay, looked at the I/O activity report and the accounting report, but there's also a statistics report. And statistics can be used to monitor the overall subsystem, the DB2 subsystem at a glance. Instead of program by program, the statistics report shows details at a system-wide level for things like buffer pools, log, locking, EVM. The short report is very useful for monitoring the buffer pools, specifically regarding I/O activity and buffer pool utilization. One statistic of interest is the dataset's open number. That can indicate the number of times a VSAM open was requested for a table space or an index. And the overall read efficiency of the buffer pool is a good thing to monitor. You can even break it down and monitor the read efficiency of random access versus sequential access as you go through the reports. Basically what read efficiency is how often does a page show up in the buffer pool when I request it versus have to go out and get it from disk. The higher the read efficiency, the better you are. Now we've looked at some buffer pool statistics that we can use to monitor I/O issues, but buffer pools do not necessarily solve all of your problems. There can be overhead in managing buffered data. I mean, the pages have to be tracked in the buffer pool. When data is requested, you may have heard the term get page. DB2 has to determine if the data is in the buffer pool or not, and if not, read the data into the buffer pool. Then there's the issue of how long does the data stay in the buffer pool, and how long should it stay in the buffer pool. If you're doing large sequential reads that can overwrite data that might need to be accessed again at some point or even soon, that can be an issue. Keep in mind, modified data too has to be tracked and eventually written from the buffer pool to disk. I talked about that a couple slides back too. So the deferred write settings control that. So buffer pools are good, but there can be overhead here too. A recent study referenced here at the bottom of the slide indicated that the total overhead of OLTP, online transaction processing, is divided up almost equally into logging, locking, latching, and buffer management. What if you could remove some of these, or maybe all of them, from the equation? Not every piece of data requires all of these activities. But if the data is in the DBMS, then these things happen. That's another reason why technology like DataKinetics Tablebase, for certain pre-selected data and applications, can help you to improve performance, sometimes relatively significantly. Another overhead issue, this time from Michael Stonebreaker. Some of you may know Michael Stonebreaker. He's one of the early relational pioneers, worked on University Ingress, and he's done some research and says that a lot of overhead is consumed communicating with APIs like ODBC, JDBC. And he made this statement in a Communications of the ACM article. It's the Association for Computing Machinery that's listed down here. So that's another issue to keep in mind. Applications that are performance sensitive, a lot of them use stored procedures, run application logic inside the DBMS to avoid the overhead of back and forth communication between the app and the DBMS. So where does this leave us? Well, keep in mind that when you use a database for data, there's intrinsic built-in overhead that can't be eliminated. That's good because it protects the integrity of the data, but it can degrade performance if these overhead items are not always required for all accessing. Things like locking. In DB2, all data, when it's accessed, except in some rare situations that I'm not going to go into, it gets locked. Even reads require S-locks, and locking adds overhead. And then there's the metadata description in the DB2 catalog and the DVD in the DB2 directory that has to be read in when data gets accessed. And also the smallest unit of data that can be read is the page. Now you can lock at a row level, but you're reading at a page level, and that's usually multiple rows. So there's lots of issues that come into play here. There's the stage 1 versus stage 2 issue and the way in which data gets read from DB2. all data comes through the vSAN Media Manager into the buffer manager, and then you apply predicates. These are the where clauses in your SQL statement. The earlier in the process you can apply those where clauses, the more efficient the statement becomes. Because if you can filter things out at the data manager level, stage 1, instead of the relational data services level, stage 2, less data gets passed along the pipe. So there's less data moving along from one section to another of DB2. And that's another issue in terms of dealing with I/O and DB2. All this information on stage 1 and stage 2 predicates is documented in the DB2 manual managing performance, SC 192978, freely downloadable over the web. So how does this all relate back to cost? Okay, for IBM MLC software, the peak R4H for the month by LPAR dictates the software bill, at least for most shops. That's if you're using subcapacity pricing like VWLC or AWLC. You submit an SCRT report, subcapacity reporting tool, monthly, and send that to IBM, and it outlines usage peaks by LPARs. And IBM sends you a bill. You can reduce cost by understanding where your peaks are and attacking the processes that are running at that time. When DB2 contributes to the peak, using DB2 tuning techniques to reduce consumption and reducing IOs to improve performance can help you improve your bill and reduce it. And you can even tune non-DB2 workload if it's running in the same LPAR and reduce the cost of DB2. So think about it in those terms when you're looking at cost reduction, not just performance tuning DB2, but what else is there. Okay, so some tuning techniques. If your R4H is in the batch window, look at your SLAs. Are you meeting your batch SLAs? If you are, and you've got a lot of extra time, maybe you want to reduce the amount of MSUs that are there during those batch processing times, especially if that's where your peak is. So you're still meeting your SLA, you got a bunch of hours at the end, why not consume them by reducing MSUs in those LPARs? Look at things like commit processing, concurrency and locking, SQL tuning, maybe putting more data into memory. What if your peak is during your transaction timeline? Look at optimizing your transactions. How can you improve the SQL? Is the workload appropriate for your systems? Maybe you can reduce MSU consumption during OLTP to reduce cost. Tune kicks. What's your resource definition online specifications in terms of kicks to DB2 communication? Again, tuning data at the tuning access at the SQL level and more data in memory are things you can look at. Okay, so before I turn things over to Randy, let me summarize some thoughts here. First of all, accessing data in memory is more efficient than accessing it from disk. And if you read a lot of data, it can be a lot cheaper. There's additional overhead to be considered in reading database data because there's a lot more that needs to be done behind the scenes to ensure data integrity. And there are methods of maintaining read-only data in memory and eliminating some of the DBMS overhead, things like DataKinetics table-based. Go out to dkl.com to take a look at what they have to offer. Remember, too, the three things that impact performance and cost: CPU, I/O, and concurrency. But don't always use the technician's terms I've thrown around here when you talk to your finance folks. If you want to get approval to buy software to attack your performance and I/O issues, you need to kind of translate that into finance speak. It's like improved profit, increased cash flow, and lower risk. These are things that will resonate with financial folks. But unfortunately, performance analysis is done by technicians, and financial analysis is done by accountants and finance pros. And we don't speak the same language at all. Now, if you recall, the goal of today's presentation is to bridge that gap between techie speak and accountant speak. And with that in mind, I want to turn it over to Randy McCoy, the CFO at DataKinetics. Okay.
Thank you, Greg.
There we go.
Okay, let me just share my presentation and then we'll get going. All right, I'll tell you a little bit more about myself. So I'm the CFO here at DataKinetics since June of 2011. I've been in finance roles for 22 years now, started in the tech sector in 1992. Used to work at Autodesk. I was based in Montreal. Autodesk, the AutoCAD maker in beautiful Marin County, California. Before DataKinetics, I used to be with Kinaxis, a supply chain software provider here in Ottawa, Canada. A lot of my time is spent as a finance partner helping the sales team, talking to customers. And I'm also a finance partner who has a sense of humor. So you're going to see a couple of Dilbert in action slides today. The goal of this side of the presentation is to help you feel a little bit less like Dilbert when you're talking to the pointy-haired boss preparing for your next business case. So a lot of people sometimes feel like this when they're asked to put together a business case. The risks and some of the concept of discounting future cash flows, they just start to feel really, really unusual because it's a different lingo. It seems like someone is talking a totally different language, and a lot of people just kind of throw their hands up in the air and say, geez, this is just not going to work. I'm going to go back to my desk now. Our goal is to help you overcome that barrier, speaking to the finance team. So as Craig said, a lot of times the performance initiative isn't linked to terms that make sense for the finance org. So you won't see anything on a balance sheet that talks about using less I/O. However, if you explain that in the context of less I/O means that we can free up our CapEx budget, we don't need to do that next big hardware upgrade, well, that's going to make a lot more sense to the finance person because reducing CapEx has a benefit on cash flow. Same idea, in-memory optimization can't really wrap your head around what that means for your income statement, but if you're able to say that I can do this technique, it'll reduce my rolling 4-hour average, and that'll save me OPEX on a quarterly basis, that's going to help our EPS improve. Well, those are definitely things that are going to resonate a lot more with your finance partner. So we want to talk about what should go in the business case template. The first thing to do is make sure if your company has a pre-approved standard template, make sure to follow that. In the event you don't have access to one, this presentation will help you at least jot down the key strawman components of a good business case. So make sure to have an exact summary and itemize the benefits, talk about your risks and how you're going to mitigate them, make your financial case, and provide a clear recommendation. And obviously the key is remember your audience, in this particular case being your finance organization. So you definitely want to be cautious to not lose them in the technology. Main advice there is you want to do this in person if possible, and you definitely want to be looking for that glossed over look in the eyes and help make sure that you help them through that. So most of my emphasis, of course, will be more on the financial components of the case. In the exec summary, you definitely want to have a quick synopsis of the problem you're trying to solve, identify the key assumptions, and in particular, finance people really appreciate doing a sensitivity analysis. So it's really valuable to have a range of possible scenarios. Do a likely project, but also prepare a financial plan that looks at a conservative estimate of what your savings might be, conservative view of your case, and then a more optimistic view of your case. And then that helps finance because you'll have a better understanding of the range, and ideally you'll want to be putting together a project that even on a conservative view, it's meeting the key financial metrics. Okay? The other thing that you always have to remember is clearly articulate the ask of what it is you're asking finance for, and sometimes you really do need to talk about it 3 times just to make sure that it sinks in and it's clear. There's definitely a reason why you'll see that in newscasts when people are talking about later tonight and coming up next and our main story. People are expecting to get a bit of that repetition. Obviously, an important part of your case is to talk through your benefits. Okay? There are certain key items that are going to resonate better with a finance organization. You certainly need to have a positive return on your investment, ROI. You want to see your operating costs saved. That's a reduction of expenses. It's good to have your capital expenditures deferred, pushed to the right, or eliminated preferably, because that'll improve your cash flow. But very important components of a good, strong business case, for sure, are projects that'll increase your revenue, increase your market share, do positive things with your customers, all very important. Another core element is something that'll decrease risk, especially if you're in a highly regulated environment where compliance is a key component. In terms of the benefits, even though you're speaking to finance, make sure to not only talk about the finance benefits. Finance is very interested in helping the business, and finance often has an integrated view of what's going on in multiple departments. So you'll want to make sure that you talk about the business and operation impacts of this project. And again, can't emphasize enough that if somehow the project is going to improve your compliance or address an audit type concern, that right out of the bat is going to be a stronger case to support you. You'll want to confirm that there are metrics which you can report on in the future to help substantiate your case. All about credibility. If you're able to measure this, then it's going to improve your odds, okay? Especially if there are key metrics, key success indicators that the company is very interested in. Okay, you'll really want to understand what those are and see how you can tie your project to that. Probably 3 or 4 times now I've already mentioned the word risk, but there is a reason for that. It's an important part of your case. The key thing to remember is that you have to identify these, but more importantly, talk about how you're going to mitigate them. Okay? So a couple of examples there. If you're looking at a particular solution with a particular vendor, you can't state that there are no competitors. It just won't be credible. One of the fiercest competitors that's always out there is the status quo. Doing nothing is a very, very fierce competitor. Never underestimate that in your case. Here's a quick example, a sample matrix that you could put together if you're looking at a partner project. For example, a lot of people will feel uncomfortable if a company is small that you're about to do business with. Well, in your business case, a good way to mitigate that risk is to demonstrate that you've spoken to that company, they actually have solid financials, they've been in business for years. If it's a software deal, talk about how you've already confirmed that the vendor has their software in escrow, so you have a backup plan in the event of an emergency. You might wonder if the company, if they're small, is able to support you. You'll definitely want to do some reference checks on the company, and in particular confirm that they have a support ecosystem such that even if something went wrong, there are other people who know how to support that product. You'll want to make sure that you've proven that the product can work. A great way to do that is to run a proof of concept in your own environment and demonstrate that you've already had a quick win and confirmation that the product will work in your company. And then a lot of people are concerned, especially in this climate, about a lack of in-house resources. In that case, make sure that you assess whether or not the company has some professional services personnel that can help you with the project, so you don't have to burden your in-house resources as much. Okay. Now it's time to put together that finance case, and a lot of people really joke about this. They feel like the finance partner is shooting these multiple acronyms at them in rapid fire. You know, oh, you got to have a high ROI, it's got to have a fast payback, you got to have the huge IRR. A lot of people aren't familiar with the acronyms, but they really don't like to ask. And sometimes it really can be, it'll feel like a diatribe where half the words in a paragraph are acronyms. You know, the EPS is down, and we have too many FTEs, and we don't have a good enough ROI, and the SEC just sent us a letter. We need to upgrade our ERP with the ABC module, and only company XYZ can do it. This is commonly the way finance people talk. So when you don't know what those things are, you're losing a little bit of the conversation right out of the get-go as you're trying to figure out, what did that mean again? I think I remember seeing that, you know, years ago in a finance class in school, but I haven't used it in a while. So one of our goals today was to help better understand that lingo. So let's demystify some of these acronyms and, more importantly, why they're used. So NPV is net present value. This is the difference between the present value of cash inflows net of cash outflows in a project. This is all about the cash profitability of a project. Okay. One of the key components here is this concept that present value is sensitive to the reliability of your future cash inflows, which is subject to the discount rate that your company uses. Now, discount rate in and of itself is called different things in many different places. So some people it'll be a discount rate, some people it'll be the hurdle rate, some people it'll be the weighted average cost of capital. The key here is to understand from your finance partner what that rate is that finance uses to assess projects, because it's an important dependency on calculating the present value of your cash flow. The simple reminder here is that if you have a strong cash flow, which is 5 years out, and your company uses a high discount rate, then the present value of that future cash flow is going to be a lot lower than you expect once it gets present valued. Whereas if you have a project where the biggest cash inflow is in year 1 or year 2, it'll have a higher present value because it's in a shorter time period. I'll talk a bit more about that later as well. IRR is the internal rate of return. This is an important concept for ranking projects. This is the rate used that would make the net present value of cash flows, which I just talked about, from your project equal to 0. So the higher the IRR, the more desirable the project is, because it means it's much higher than your hurdle rate or discount factor. Okay? So again, the key is if you're looking at 100 different projects and you only have staffing for 20, this metric will be one of the key components used in assessing the projects from a financial perspective. ROI, most people are more familiar with this one. It's the return on your investment. That's a performance measure. It's a percentage calculation, and it really evaluates the overall efficiency of that investment. Okay? It's your benefit over your cost. Okay. Payback, this is actually one of my favorite metrics. It's actually simpler to understand, and the concept is very logical. This is just the length of time required to recover the cost of your investment. So the shorter the payback, the more attractive it is, and that ties in with the same financial theory as the net present value methodology. So cash inflows which occur quickly are worth more than a cash benefit which is 5 years out, because it's inherently more risky the further away it is. Let's go in a little bit more about financial cases. So now that you know what all those acronyms mean, which one do you think your finance partner would most prefer? Well, the typical finance answer is, it depends, similar to a common IT answer. Here's the thing. They're all important. All these metrics are very important. The key is, which one is the most important right now? That's what we need to talk about. And it really could change quarter to quarter. And it's not because finance is flip-flopping on you. It really does mean that as conditions change, the metric which is most important will also change. So here's one of the reasons why you're getting that "it depends" answer from finance. Sometimes it's a compensation issue. People are comped on different metrics. So if what you're most looking for is a cost reduction in the current year, then the project with a short payback is going to be more valuable than one that might have a higher ROI percentage, but the return is back-end loaded. Remember, I talked a lot about the rapid payback concept. If the benefit is too late, it won't necessarily be helping you. Okay? Whereas on the other hand, some companies, the customers that come to mind for me here are in the defense and aerospace sector, where they were all about efficiency over the long term. Projects were multi-years in nature, and they knew they were committed. So they were willing to accept a 3-year payback as long as they were sure the platform they were supporting would be around that long. The timeline made sense to them. Of course, a lot of our customers are public companies, so quarterly earnings are very important. So EPS is a big deal. In particular, if your forecast is showing that you may have some EPS pressure next quarter, then a short payback project may be very attractive because it can actually help you in the immediate term. Whereas with a private company, they're potentially less concerned about EPS. For them, cash is king. Whatever project gives them the biggest bucket of cash is going to be much more attractive. Very important to understand how the budget is put together. People budget differently. So some people would prefer to see a large purchase coming out of their OPEX budget, which is your operating costs. Some of the comments that I've heard is there's a lot less red tape to cut through to get approval out of the OPEX budget. Other people, again, I think back to some of the defense and aerospace environments, CapEx, the capital expenditure budget, was a lot more plentiful because that's the way budgets had already been put together for large acquisitions, was they had to go through the CapEx budget process. The reason why I mention this is because some vendors might be able to help you depending upon which budget bucket you can access more easily. For example, a lot of companies are able to put a subscription or time-based software rental contract through the operating expense budget, whereas a perpetual software license fee will typically have to be put through the CapEx budget. So you can see why it's so important to understand which budget is more available, and remember that one size certainly does not fit all when it comes to budgeting. And you know the budgeting is very important in the finance world and the IT world, because even our friend Dilbert has seen things go wrong putting budgets together. as you can see from this. What else is left? Hey, when it's time to put the finance case together, you'll definitely want to refresh your Excel skills. Most companies, of course, will have a template. I'll show you a simple example on the next page. This is another one where it really depends on what the organization is like. Some will be very simple and straightforward. Some will be very complex and locked down with pages and pages of rules on how to use the template. My best piece of advice here is try to find a friend in finance who can help you navigate the financial case template. And sometimes certain suppliers will have a finance partner who helps the sales organization, and of course they'd always be happy to help work with you as you build the business case. You just of course have to be cautious not to cross any of the confidentiality lines for sensitive information. Okay, so here's just a simple illustrative example to highlight a couple of these points. So obviously your cash inflows are the benefits of your project. The cash outflows are the costs associated with the project. So you'll just want to get a quick snapshot of the net cash flow impact, and then that discount rate or hurdle rate, whatever your organization calls it. This is something that you'll need to obtain. If you can't obtain the real one, then my best advice there is do a range of rates where maybe you'll have a low conservative rate of a 10%, a 15% for a more likely, and then a higher risk rate, say 25%. And you'll see the different impacts that those have. The higher the rate, the lower your present value of cash flows will be, especially for those future years. Okay, so you use a model like this to calculate those key metrics, which are bolded towards the bottom of the spreadsheet. Calculate your NPV, which you now know is net present value, which is really today's measure of the cash flows of this project. Calculate your IRR. So you can see the internal rate of return on this project is 43%, which far exceeds the 15% hurdle rate. So you've got a check box in that metric. The payback is measured in months. It's under 1 year, which is often going to be a requirement for finance to look at a project, especially if you're resource constrained. You're definitely going to be focused on the projects that have the better bang for the buck quicker. And then, of course, what's the overall ROI of this project? The main thing I really wanted to emphasize on this and remind people to consider is that time value of money impact. So the quicker the cash flow benefits occur, the better it is for your case. Okay. So then after you've walked through those components of your business case, then you want to provide a summary recommendation, restate what it is the solution solves, show that it delivers on the benefits that you've talked about, show that you've mitigated the key risks, and then demonstrate that there's a financial case which passes the test, and you have check marks on the right metrics which are relevant to the division or the corporate objectives, and then clearly articulate exactly what it is you're asking for. Are you talking about, are you asking for approval to proceed? Are you asking for budget for next year? Just be clear so your finance partner can best help you. Okay, so hopefully with this summary, you'll have a more successful process with your finance partner for the next business case you put forth. And remember, don't view your finance partner as an accounting troll. They really are there to help you and aligned with pushing business forward. However, Gilbert does have a little bit of a point here. Budget season is a bit of a tricky time for your finance friend. So there are a handful of times when you should avoid them. Budget season is tricky, quarter end is tricky, year end is especially tricky, tax season is maybe a bit dangerous for you, audit time. Oh, and especially if the SEC calls, that could be a tough time for your finance partner. But other than that, it's all good. What other times are left, eh, Craig?
Yeah, exactly. Kind of reminds me of a story I used to tell to folks when I worked as a DBA at a bank back in the East. People come to me and say, oh, there's problems with performance with DB2, and I'd say, well, you have to understand around here that the 15 days before and the 15 days after month end, performance pretty bad. They'd wrinkle up their nose, think about it for a minute, get rid of them for a minute or two, but they'd always be back.
Buy you at least a little bit of time.
Right.
There's some IT finance humor for everybody. Thanks for your time, Craig. Thanks everyone for listening, and please feel free to contact either of us with any questions you may have. There's contact information for both of us on this page. Have a good day.